So we all love sports. Just sometimes not as much. If you've ever had a torn muscle or a twisted ankle, you know that it feels a whole lot better when you put one of these ice packs on, right? And other times when our muscles tense up, we apply heat packs instead. But have you ever thought about what happens inside of these packages? Alright, so the thing that makes heat packs and cold packs actually work are examples of reactions in chemistry we refer to as exothermic and endothermic reactions. An exothermic reaction gives off heat, while an endothermic reaction pulls heat from the surroundings and therefore becoming cold. To do these two experiments, these are the things we're going to need.
Some kind of cold salt, for example ammonium nitrate. Water. Sodium acetate trihydrate. Beakers and the lid. Spoons. Thermometer. A large beaker to use as a water bath. And a hot plate.
Alright, we're going to start with the cold pack. Inside this pack we have the two chemicals already, but they are separated from each other. We have ammonium nitrate, which is a crystal, and we have water, which is obviously a liquid. When we break an inner membrane, the two chemicals will mix and the ammonium nitrate will dissolve in the water.
And we can do this same reaction here in the lab. Start by pouring about 100 milliliters of water into a beaker, which will simulate the plastic bag. And then we will just add and quickly dissolve about 10 teaspoons of ammonium nitrate in the water.
You will really be able to feel this when you try it yourself. You just put your hand on the beaker and you can feel how cold it gets. And you can try it with different salts. For example, normal table salt, sodium chloride, works. But the thing is that there is a difference in the temperature change that you will notice. So why do you think that is? Well, there's something for you to think about. So now we're going to put this one away and we're going to move on to our second reaction, the exothermic reaction. For this reaction, we will start with a chemical called sodium acetate trihydrate, which is essentially sodium acetate with 3 water molecules bound to it. Let's do it.
First, heat up a water bath to about boiling temperature. Then add a few spoons of sodium acetate trihydrate crystals to a smaller beaker. Put the beaker in the hot water bath and wait for it to melt. You may have to add some extra water as the salt is getting close to melting. And when all the salt is melted, make sure there are no solid crystals left, not in the solution or on the glass. Then carefully take the beaker out of the water bath and let it cool to room temperature.
Yep, the solution is now at room temperature and we have what is called a supersaturated solution of sodium acetate trihydrate. Let me try to explain what a supersaturated solution is.
A supersaturated solution of sodium acetate trihydrate actually contains more dissolved sodium acetate trihydrate than you would normally be able to dissolve. And this was made possible because we prepared it on the hot plate.
Basically, at around 54 degrees Celsius, the salt that is now dissolved in the solution wants to go back to a solid crystal state. But it won't happen until something disturbs the solution. So you might have seen that in some hand warmers or heat packs, you have to snap something inside of them to actually turn on the heat. And we're not going to do that, but what we're going to do is we're going to drop a crystal of sodium acetate trihydrate into the solution to create that disturbance and see what happens. Check this out. That's one of my favorite experiments. The salt is back to solid and the beaker definitely warm. Exothermic reaction. So now we've done the reactions that happen both inside an ice pack and a heat pack. But think about this one. Why do you think the pain goes down when we put an ice pack on our injury? The science behind this one is actually pretty cool too, so I suggest you look it up. Alright, that's all we have today. Good luck and have fun.